All right, welcome to day 3 of chapter 2. Today we're going to talk about factoring polynomials. So this is all review from grade 10 today, but it's a huge idea for us in grade 11. So this is one of those skills that kind of knocks people down this year if you don't remember it. So today's our chance to go over it and ask any questions about anything that's unclear from last year. My grade 12s into calculus are still using factoring. You're still going to use it into university. It's a basic skill, so we really need to make sure that we have mastered it going forward. So the first thing that I want to understand is the relationship between these two expressions. So I've got x plus 3 times x minus 4 is the same as or equal to x squared minus x minus 12. Now, if you were to start on the left side of this, so if I were to give you the x plus 3 times x minus 4, and you were to change it to this side, so if you were to move from the left to the right, that's what we call expanding. And the operation that we're using there, if we were thinking about arithmetic, is multiplication. So this is really just multiplying. What we're looking at today, though, is going backwards. What if I started with the x squared minus x minus 12, and I wanted you to go back and tell me what it was in brackets? Now, it turns out that the brackets form is actually more useful to us more often. So that's usually our goal, especially heading forward. When I go backwards this way, we call it factoring. So I want to change it and write it as an expression of its factors. Just like you did, you guys did like prime factorizations when you were in grade school, and you would have like had a number like 12 and you would have stated the factors of 12. So I could say that the factors of 12 are 3 times 4, right? So I'm just changing the number and writing it as a multiplication statement. That was how I stated the factors. And then if you did prime factorization, you would have said, well, 4 is the same as 2 times 2. And so that would be my prime factorization of 12. We call that fully factoring in when we're talking about algebra. And of course here what I'm doing is dividing, right? To go backwards and try to figure out what the multiplication statement is, that's the same as asking myself, like, what can I divide 12 by? Or what can I divide this algebraic statement by? A little bit harder with that algebra. So I'm going to go through a bunch of different types, 6 different types of factoring today. And the first one here, common factoring, is the one that I always start with. It's my easiest kind of factoring. It's the one we learned in grade 9. And what I'm looking for is just a common factor that I can divide out of all of the terms. So it doesn't matter how many terms there are, I need to be able to divide all of them by this number, or this algebraic expression. So here, what I'm going to do is take a look first at the coefficients. I have the coefficient 3, 12, and negative 15. And I notice that I can divide all of those numbers by 3. So I'm going to put that 3 out front. It's going to be the thing I multiply my other expression by to get back to this. And then I'm going to look at how many m's are being multiplied in each of the terms. So the first term has an m squared. That's an m times another m. And then the second term just has 1m, and the third term has 3 m's being multiplied. So that means that I can divide out at least 1m from all 3 terms. So now what I'm going to do is divide each of those 3 terms by 3m. And that's going to tell me really what would I need to multiply together to get back to my original expression. So my first term was 3m squared, and I'm thinking about dividing it by 3m. So 3 divided by 3, I'm dividing the coefficients, is 1. You can write that down if you want to. And then m squared divided by m. You might be remembering your exponent laws, which tell you can subtract exponents when you're dividing. Or you might just be thinking, well, m squared, that's m times m. And if I divide that by m, I can cancel, and I'll be left with just m. So I know that when I do 3m squared divided by 3m, I'm just left with an m. Moving on to the next term in my original polynomial, I'm looking at positive 12m. So first I divide the coefficients, 12 divided by 3, that gives me 4, and it's positive. And then m divided by m, I'm left with no more m's. That's the end of that one. And then taking a look at, and m divided by m, sorry, is equal to 1. So I've got 4 times 1, which is just 4. And then my last term here, negative 15m cubed. Again, look at the coefficients first. Negative 15 divided by 3 is negative 5. And then I've got 3 m's being multiplied, but I'm dividing one of them away, so I'm left with 2 n's being multiplied. Now, we don't love this format. Normally, I would rewrite this so that I have my largest exponent on m first. So I'm going to put the negative 5m squared first, and then the m, and then plus 4. You could have also factored out that negative. You could have put that in front, but then you would have to divide all 3 terms in the bracket by negative 1. Our second type of factoring is factoring by grouping. So we're going to do a couple of examples here. When I factor by grouping, typically what I'm looking at the beginning of the question is a group of 4 terms. So here I have a polynomial in 4 separate terms, and I'm going to group the first pair together and then group the second pair together. And then I'm just looking for a common factor in each of those groups. So whenever I have 4 terms, I'm looking for grouping them together. Is there a way to factor something out of each pair? So here I've got k cubed plus 3k squared. There's no coefficient I can take out of both. I could divide them both by 1, but that's not really interesting. I can take 2 k's from both, so I can divide both of them by k squared. And so I'll open up a bracket and I'll ask myself what's left over. So k cubed divided by k squared. I had 3 k's being multiplied, but I divided 2 of them away, and I'm left with just 1 k. And then in the second term, positive 3, that's my coefficient, and I'm dividing by a coefficient of 1. So it's still just 3. And then k squared divided by k squared, that's equal to 1. So 3 times 1, I just leave it as 3. I close up that bracket and then I move on to the second pair. So the second pair, negative 2k minus 6, I'm looking for something that I can divide out of both of those. And I can divide them both, I see, by the coefficient 2. But I'm going to take the negative with it. And I will talk about why I wanted to do that afterwards. So sometimes I want to take the negative and sometimes I don't. So I'm going to divide both of these terms by negative 2. I couldn't take any k's. I couldn't divide the last term by k, so I can't take any. So looking at the first term, negative 2k, dividing it by negative 2, I get positive 1 times k. And then looking at the second term, negative 6 divided by negative 2, and I get positive 3. So negative divided by negative is a positive. And now this is what I was hoping for. So whenever I'm factoring by grouping, I'm hoping that I end up with 2 matching brackets. And I see here that in my first term, I'm going to call this now my first term, I have k squared times this bracket. And in my second term, negative 2 times this bracket, there's a common factor of k plus 3. So I'm going to pull out that common factor of k plus 3, and then I'm just going to write down the leftovers. So if I divided that first term, the yellow highlight, by k plus 3, what would be left over? K squared. And then if I divided that second term, the green highlight, by k plus 3, what would be left? Just the negative 2. And so that simplified down really nicely. All right, the next one we're going to take a look at is 3y times y plus 2 minus 4 times y plus 2. And hopefully you're noticing this kind of looks like the second line of our last example. Again, I have a matching bracket, and I'm thinking about these as being 2 different terms. So here I've got my first term, and here I've got my second term. So when I take a look at this, both of my terms have a common factor of y plus 2. I'm going to bring it out front. And then I'm going to ask myself, what's left if I divide the green term by y plus 2? And I'd be left with that 3y coefficient. And then what's left if I divide the blue term by y plus 2? Just the minus 4, that coefficient. And so again, that factored out really nicely. Don't forget, whenever you want to check your factoring work, for instance, going back to example A here in number 2, I could just multiply this back out and multiply this back out and collect like terms and see if I end up with what I started with. And if I did it correctly. All right, our third type is simple trinomials. And some of you have seen some of this in the homework so far. Simple trinomial is special because there's a 1 in front of the x squared. So when I look at example A here, I see that there's a 1 in front of the x squared, and that's what makes this simple. All I have to do then is try to figure out what were in the two brackets that multiplied together and simplified out. So I collected the like terms, and I got x squared minus 3x minus 40. Now, if I think about multiplying these two brackets together, the two numbers at the end would have to multiply together to give me the negative 40. And that's why last year your trick that you were told was go off to the side and try to figure out two numbers that have a product of negative 40. And that's because when I expand, it'll add up. It'll multiply together to that. And then you were also told that those two numbers needed to add together to be negative 3. And that's because those are the two terms that you're going to collect, the like terms that you'll collect. So I need the product to be negative 40 and the sum to be negative 3. So I'm going to think through all the numbers that multiply to negative 40, so maybe like negative 10 and 4. And I'm just going to keep going through here. I could do negative 5 and 8. Ooh, that's kind of close because that gave me positive 3. So then I'll just switch the signs around, and I'm going to get negative 3. So that's my pair right there. And simple trinomial factoring is really nice because you just get to pop those two numbers right into the brackets. So I know that the two numbers that I needed were positive 5 and negative 8. And just double check that. When you multiplied it back out, you're going to get the negative 40, and when you add them together, you're going to get the negative 3. At the front of the bracket, if you were thinking about what needs to go at the front here, well, the two front numbers need to multiply to the front number in your trinomial. That's why with a simple trinomial, it's x and x to get my x squared. Don't forget I can check my work by foiling or multiplying, expanding that back out. So you might be looking at part B and asking yourself, like, why'd she put this one here? There's no 1 in front of the x squared. And simple trinomials have to have a 1 in front of the x squared. But don't forget, every single question, I start by looking for a common factor. So here, when I look at all three of these coefficients, I notice that I can divide them all by 3. So I'm going to take that 3 out in front of the bracket. That means I'm dividing all three terms by 3 to tell me the leftovers. So 3x squared divided by 3 is just x squared. 9x divided by 3 is 3x. And 6 divided by 3 is 2. So now I've got that bracket, and this is good. It's factored, but it's not fully factored because I can continue to factor that leftover bracket. That leftover bracket is a simple trinomial because there's a 1 in front of the x squared. So I'm going to come off to the side again, and I'm going to think about what two numbers would give me a product of the last number, that's the 2, and would also give me a sum or add up to the 3. So I want to multiply to the end and add to the middle. And so, of course, here my two numbers are 1 and 2. And because it's a simple trinomial, I can just pop them into brackets. So I'm going to put the plus 1 and the plus 2 right into the brackets. Again, to get the x squared at the beginning, I need x times x. Now, don't forget, if I want to multiply this out and get back to the original line that I started with, I still need to triple everything. So that 3 is still tagging along. All right, our fourth type of factoring that we're going to take a look at is difference of squares. So I really want you to think about the title of this. When I use the word difference, difference means subtraction. And squares means two numbers that are perfect squares. So perfect squares, when I'm thinking about numbers, that would be 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared, 6 squared. And hopefully you can go on a bit further than that and you start to recognize some of those numbers. Or it could be a variable squared. So x squared is a perfect square. And x to the power of 4 is actually equal to x squared times x squared. X to the power of 6 is x cubed times x cubed. X to the power of 8 is x to the power of 4 times x to the power of 4. So hopefully you're seeing a pattern with those exponents, and you're noticing that any even exponent is actually a perfect square. So I need to recognize that, and so when I look at each one of these questions to find a difference of squares, I'm looking for just two terms, and the two terms are being subtracted, and they're both perfect squares, so they both show up on one of those lists. So when I look at the first one, this is awesome. I've got two terms, they're being subtracted, and they're both perfect squares. Now, our trick for this is to take the square root of the first term. So x squared, the square root of x squared is x. X times x will give me the x squared back. Remember, I'm thinking about multiplying it back together. And then I want two numbers that multiply to give me negative 16. And with difference of squares, that number is always going to come from the square root of 16. Now the square root of 16 is 4. But when I multiply this together, I want to get negative 16. So I need one of them to be positive and one of them to be negative. Don't forget you can check your work by multiplying this back out. And let's take a look at how does this turn into just two terms. So if I do x times x, I get x squared. X times negative 4, negative 4x. 4 times x, and 4 times negative 4. And what happens with difference of squares is the two middle terms are always going to cancel each other out. So here, my negative 4x plus 4x, that's just 0. And they go away, and I'm left with x squared minus 16, which is what I started with. So I know that my answer is right. All right, moving on to part B. When you look at this, I hope right away you notice that this is not a difference of squares. It is a difference, it's subtraction. But 75 is not a perfect square, and 3 is not a perfect square. Again, don't forget I can always check first for a common factor. So here I see that I have a common factor of 3. 75 divided by 3 is 25, and the p squared is still there. And then negative 3 divided by 3 is negative 1. So now I've got 3 out in front, and inside the bracket I have a perfect square minus another perfect square. Don't forget that 1 is a perfect square. So I can use my trick again. The 3 is still hanging out, and I know that the difference of squares turns into two different brackets. At the beginning of each bracket goes the square root of the first thing. So the first thing was 25 p squared. The square root of 25 is 5. And the square root of p squared is p. So I'm going to put 5p at the beginning of each bracket. Imagine multiplying that back out. It makes sense, you would get 25p squared back. Now at the end of each bracket, I need to have two numbers, and they're going to come from the square root of the last number. So the square root of 1 is 1. And then in order to multiply these together and have the middle terms cancel out and end up with a negative 1, I need 1 to be positive and 1 to be negative. The order doesn't matter. You could put the subtraction in the first bracket or in the second bracket. Again, you could check your work by multiplying this back out. All right, number 5 is decomposition. It's not our favorite type of factoring because it's cumbersome. It takes a long time, but sometimes it is necessary. Last year, your teacher might have called it decomposition, or they might have called it complex trinomial factoring. Same thing. There are actually lots of different methods to do this, but this is typically the method that we teach here. If you have another method and you want to ask me about it, you can ask me in class to see if you're showing me enough work. Don't forget that whenever I start a question, I'm looking for a common factor. So when I look at this first question here, I notice that I can take out a common factor of 2 from each of these terms. I can divide all of them by 2. That's what when I'm saying take a common factor out, I mean divide it out. So 12x squared divided by 2 is 6x squared. Negative 2x divided by 2 is negative 1x. You can write the 1, but you don't have to. And then negative 2 divided by 2 is negative 1. So I've divided out that common factor, and it just makes the numbers in the brackets a little bit smaller. Now I can still factor that bracket though. The 2 is just going to hang out for the rest of my question. And I'm going to imagine how can I factor these 3 terms. And I can't use my simple trinomial factoring. I want to use my factoring by grouping. So thinking back to number 2 here, when I had 4 terms, I had a method for grouping them. So I wanted to group the first 2 and group the last 2. So what I really wish I could do is take this middle term here and decompose it into 2 terms that are also equal to negative 1x. And that way I can group the 4 terms. So I still want these two terms to add up to negative 1x. So I'm leaving the first term alone, leaving the last term alone, and I'm going to decompose this middle term into two terms. In order to come up with the numbers that I should use, because lots of pairs add up to negative 1, right? I could use like negative 3 and positive 2, or negative 4 and positive 3, and negative 5 and positive 4. There's lots of different pairs that add up to negative 1. So what I actually also need is for them to multiply to the first number times the last number. So 6 times negative 1 is negative 6. So I need the product to be negative 6, and like we said, we need the sum to be negative 1. So I'm going through all my pairs that multiply to negative 6, and I notice that negative 3 and 2 multiply to negative 6, and negative 3 plus 2 give me an answer of negative 1. So those are my two numbers. And that makes sense because negative 3x plus 2x, if I thought about putting those two together, I would get back the negative x that I had. So I've just taken the negative x apart. And now what I'm left with in those brackets is two terms that I can group and another two terms that I can group. So this is what I was hoping for. The 2 is still hanging out, and I'm just going to look at those first two terms, 6x squared minus 3x, and look for common factors. So I see that I can divide them both by 3x. And what's left over when I do 6x squared divided by 3x? I get 2x. And negative 3x divided by 3x is negative 1. Now when I look at the second pair of factors, there's no common factor. Whenever there's no common factor, you can still divide by something. You can always divide by 1. So I'm going to divide both of these terms by positive 1, and I get 2x minus 1. This is good news. This is what I was hoping for. I wanted two terms inside the bracket. That had two matching brackets, so two matching factors. But don't forget that 2 is still out front. I can't get rid of him. But now I'm going to pull the 2x minus 1. It's in common. My yellow term and my green term both have a 2x minus 1. When I divide the yellow term by 2x minus 1, I'm left with 3x. And when I divide the green term by 2x minus 1, I'm left with positive 1. And ta-da, I'm done. I can't factor any of those brackets any further, so I'm finished. I could check my answer by multiplying this all back out, and I should end up right back at the top with what I started with. All right, taking a look at part B. This time I first check for common factors, and there are no common factors. So I'm going to go right into decomposition. That means that the first term stays the same, and I'm trying to split up that middle term so that I end up with factoring by grouping those four terms. So the plus 6 is still staying the same at the end as well. Don't forget my trick to come up with the right pair of numbers that add up to 7, because there's lots of numbers that add up to 7. 8 and negative 1, or 3 and 4, lots of different pairs, is I need them to have a product of the first number times the last number. So 2 times 6 is 12. And then I also need them to have a sum of the middle number. That's 7. So I go through all the numbers that multiply to 12. So I can use 1 and 12, 2 and 6, 3 and 4. And I see there's my pair. 3 times 4 gives me 12, and 3 plus 4 gives me 7. So I'm going to decompose that middle term 7x. It's the same as 3x plus 4x. And the order doesn't matter. Maybe you did 4x plus 3x. That's fine. You'll get the same answer as me at the end. Now that I have 4 terms, I can use my factoring by grouping trick. So I'm going to group the first 2 terms and look for a common factor that I can divide both of them by. I can divide them both by x. So 2x squared divided by x is 2x, and 3x divided by x is 3. In the second pair of terms, again, I'm looking for a common factor that I can divide them both by. So I can divide them both by 2. 4x divided by 2 is 2x, and 6 divided by 2 is 3. Again, what I've got here is 2 terms, and they both have the same bracket as a common factor. I'm going to bring that common bracket out front, and then ask myself what's left over when I divide the first term by that bracket. I'm just left with an x. And what's left over when I divide the second term by that bracket? I'm just left with a 2. And it's a positive 2. Don't forget I can check my answer by multiplying that back out. All right, one more kind of factoring. It's perfect square trinomials. This is not a necessary type of factoring for you to know, but it's a shortcut. So the shortcut sometimes works and sometimes doesn't. What I'm looking for is a perfect square trinomial. So how do I identify? First, I have to check if it's a perfect square trinomial. So the first thing that I need to check before I can use this trick, there's three things. The first thing I need to check is that I can square root the first term. So I'm going to square root, and just so you can help remember how this goes, I want to be able to square root the first term. So in this case, I want to be able to square root 9x squared. And I can do that. I can take the square root of 9, it's 3. And I can take the square root of x squared, that would just be x. So that's a check, that's a go. The next thing I need to check is that I can square root the last term. So I square root 25 is my last term. And I can square root 25, that's 5. So making sure that there's no decimals and that I can square root the exponents on the variables. Now the last thing that I need to check is that the middle term is equal to 2 times the square root of the first term times the square root of the last term. So those two answers that I just came up with. Now my middle term in my expression is 30x. So this is kind of a question mark at this point. I don't actually know if they're equal, so I shouldn't actually be using an equal sign there. What I'm checking is what is 2 times the square root of the first term we said was 3x, and the square root of the last term is 5. When I simplify that right-hand side here, I get 2 times 3 times 5. You can just multiply all the coefficients together, and that is 30, and then just an x hanging out. So I do get that the middle is equal to 2 times the square root of the first term times the square root of the last term. Be careful, this won't always work. You do need to check those 3 things. Now, once I know that all 3 of those checked out, I can use this shortcut. I take the square root of the first thing and I put it at the front of the bracket, and then I take the square root of the last thing and I put it at the back of the bracket. And then what I'm going to do is take the first sign. So my first sign in my expression was adding. So I'm going to add in here, and then I'm going to square this bracket. And that's a nice kind of shortcut trick, isn't it? There's a lot of work up front for checking, but imagine multiplying this back out. You don't have to do this in this question, it just said to factor. But if I wanted to multiply this back out, it works because I'm taking the square root, the 3x, and multiplying it by itself, which gets me back to what I started with, the 9x squared. And then what I'm going to get is 2 of the square root of the first thing times the square root of the last thing. That's 2 3x's times 5. So first I get the 3x times this 5, that's 15x. And then I get this 5 times this 3x. Again, that's 15x. So I get 2 of them, which is what my last check was here. Do I get 2 of the first times the last when I get to the middle? And then, of course, when I multiply the last 2 terms, I get 25, 5 times 5. And I can see that these 2 middle terms here, 15 plus 15, will give me back the 30x. So I'm happy. Again, your final answer would be just here, though. We're going to try one more example of that. Handy little trick if you happen to notice it, but again, you don't have to use this trick. So for the part B here, I'm going to check a couple of things. I want to check the square root of the first. So I'm checking the square root of 4m squared, and I can do that. The square root of 4 is 2, and the square root of m squared is m. And then I check the square root of the last term. My last term here is positive 1, and I can square root positive 1, it's 1. And then the last thing that I need to check is what is 2 times the square root of the first times the square root of the last. If it's equal to my middle term, then I can use my shortcut trick. So 2 times, we said the square root of the first thing was 2m. and we said the square root of the last thing was 1. And when I multiply those together, I get positive 4m. Now, a little bit tricky here because in the question it's a negative, but this still checks out for me. So I could square root the first, I could square root the last, and I actually don't care if it's positive or negative 4m and negative 4m. It doesn't really matter for this trick. So for my trick of factoring, don't forget that it's going to be the same bracket twice. So the same bracket squared. I put the square root of the first thing at the beginning, the square root of the last thing at the end, and then I take the sign from the first term. So this is where that subtraction is going to come back. We said we could ignore it before, but now we're going to add it back in. And so it's 2m minus 1 all being squared. Now if you didn't notice this trick, you didn't even think to check for perfect squares, that's okay. You can still use decomposition on these types of questions, and it'll work. So you should have some homework on your guide online, and I believe there's also an extra homework handout about factoring in the Schoology folder. Good luck!